Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We started a discussion with the chapter Integration. We did a few reduction formulas techniques, right? Fine. With the continuation of that, let us do the last cosecant power n. We did for sine power n, cos power n as by taking sine power n minus 1 into sine, right? Fine. Similarly for cos also, cos power n minus 1 also we did. Next, tan and cot we did tan n power n minus 2 like that. For secant also we did power n minus 2. With the continuation of that, on the same lines, let us write cosecant also, cosecant power n minus 2x. Okay. So, let us write in as integral cosecant power n minus 2x into cosecant square x dx. Now, can we find integral of cosecant square? Obviously. So, let us continue on the same thing. So, u integral v dx minus integral du by dx, differentiation of cosecant power n minus 2x into integral cosecant square x dx whole dx. Now, this is cosecant power n minus 2x, cosecant square ka integration is minus cot x. Now, here differentiation of this n into x power n minus 1 into cosecant ka integration is minus cosecant x cot x into cosecant square ka integration is minus cot x whole dx. Yes. Now, let us multiply and simplify everything. What can I get? Minus cosecant power n minus 2x cot x. Here minus 2, here minus to minus already it is plus, so I will write only 1 minus into integral cosecant power n minus 3x minus 3 into cosecant, this will be cosecant power n minus 2, right? And next cot into cot, this is cot square x dx. Now, what is our next step? We do not know integration of cot square, so we will write it as cosecant square minus 1. So, this will be minus cosecant power n minus 2x cot x minus n minus 2 into integral cosecant power n minus 2x, this can be written as cosecant square x minus 1 dx, right. Now, let us multiply, we will get it as minus cosecant power n minus 2x cot x minus n minus 2 integral cosecant power n minus 2 square, this will be nx dx minus to minus plus n minus 2 integral cosecant power n minus 2x dx, right. Now, what is this? In is equal to minus cosecant power n minus 2x cot x minus, this is n minus 2 into this is in plus n minus 2 and this is in minus 2. Is it fine? Okay. Now, let us take this term to left hand side. So, what do I get? If I take in common, I will get it as 1 plus n minus 2 is equal to cosecant power n minus 2x cot x plus n minus 2 in minus 2. What is 1 minus 2? That is nothing but n minus 1. So, I will get it as in is equal to minus cosecant power n minus 2x cot x by n minus 1 plus n minus 2 by n minus 1 in minus 2. Clear? Is it fine? This is what the reduced formula for integral cosecant power nx dx. Now, let us reduce this I phi. Same as we did in the last problem, last session ka problem, we will do the same thing. We will find all first and we will substitute it. I phi is minus cosecant phi minus 2, that is 3x cot x by phi minus 1 is 4 plus 5 minus 2 by 5 minus 1. What is it? 3 by 4i. 5 minus 2 is 3. Right? Or else let us continue the same. Minus cosecant cube x cot x by 4 plus 3 by 4 into what is I3? Minus cosecant 3 minus 2 is 1 by 3 minus 1 is 2 cot x plus 3 minus 2 is 1 by 3 minus 1 is 2 I1. Okay. What is I1? I1 is nothing but integral of cosecant x. What is integral of cosecant x? Let me write it here itself. Log of cosecant x minus cot x plus c. That's it. This is the answer. Now let us write all together. Therefore, I5 is minus 1 by 4 cosecant cube x cot x by there is already by 4, right, plus 3 by 4 into 2, that is minus 3 by 8 cosecant x cot x with this plus 3 by 8 log cosecant x minus cot x plus c. Is it right? These are the basic reduction formulas of trigonometric functions. What if I have the combination of sine cos? What will be the reduction formula for that? Fine. Let us do those kind of combinations now. Look at the next question here. Here he gave Imn is equal to integral sine power mx cos power nx dx. Imn, that is not just a m or that is not just n. Here m indicates the power of sine, n indicates the power of sine. Power of cos. So, based on the variation between m and n, we can use this both the formulas. We will get the both if we derive. But if m is greater than n, we are going to use this formula. If m is less than n, we are going to use this formula. Here m is greater than n, here m is less than n. Is it clear? So, let us derive this one of the formula and you can easily understand the other. Shall we? See here. Now, let me take, how did we derive for sine or cos? We used either sine power m minus 1 or cos power m minus 1 in that. So, we have both. So, what shall we do? Let us take any one of them. Okay. For the first, let us take cos power n minus 1. Let us put sine as it is. Let us write cos power nx n minus 1 into cos x dx. Clear? Is it okay? Now let us simplify this. This is u and this is v. Now u into v dx is integration, that is sin x, right? Is it okay? U into integral v dx minus integral differentiation of this term uv. So, let me write uv dash. First, sine will put as it is n minus 1 cos power n minus 2x into cos ka differentiation is minus sin x, right. Next, v u dash cos power n minus 1 into sin power m ka differentiation m sin power m minus 1 into cos x, right. Differentiation of this term into integration of this whole into integration of cos is sin x dx. Is it right? Now, let us simplify this. What do I get? Sin power m into sin x, that is sin power m plus 1 x into cos power n minus 1 x. Here, now multiply everything, this term into sin, this term into sin. Is it okay? So, minus into minus plus sin power m plus 1 plus 2, that is sin power m plus 2 x. Okay, let me write n minus 1 first. Okay, n minus 1 into integral sin power m 1 2, this is sin power m plus 2 x cos power n minus 2 x dx. Is it okay? Now the next, here m is left, m, and that is it, right. So let us write it as minus m integral cos power n minus 1 plus 1, this is cos power nx, and here sin power m minus 1, and here this will be sin power m x dx. Is it clear? Any discussion? Nothing, right. So now let us write all together and simplify. What do we get? Here it is n minus 1 into this term. So this one it's fine, here it's fine, but we have to find the integration of this term. Okay. So how do we get? Now just tell me, integration of sin power m plus 2x cos power n minus 2x dx. So how do we simplify this? If you observe, here it is sin power m plus 2, that is sin power m into sin square. So and here it is cos power minus 2. So let us write this sin square as 1 minus cos square. So what do we get? Sin power m plus 1 x cos power n minus 1 x plus n minus 1 into integral sin power mx into 1 minus cos square x into cos power n minus 2x dx minus m into, what is this? This is imn. Is it okay? Now the next term is this particular thing. So let us take sin power m plus 1 x cos power n minus 1 x plus, let us multiply now, n minus 1 sin power m into 1 into this, that is integral sin power m into x cos power n minus 2 x dx minus n minus 1 into integral sin power m cos power 2 into this, that will be sin power mx into cos power 2 into cos power n minus 2, that is nothing but cos power nx dx minus m I mn. Okay. Now just see here, I mn is equal to sin power m plus 1 x cos power n minus 1 x plus n minus 1. What is this? I m n minus 2? Yes, right. What about this? N minus 1 into, this is I m n, and here m I m n. Is it clear? Now let us take this I m n and I m n two terms to left hand side. So if I take I m n common, so I will get it as 1 plus this term n minus 1 plus this term. Clear? And remaining right hand terms as it is. So I will get it as sin power m plus 1 x cos power n minus 1 x plus n minus 1 I m comma n minus 2. Right. Now just see here, 1 will get cancelled, I will be left with m plus n. So I m comma n will be sin power m plus 1 x cos power n minus 1 x by m plus n minus 1 by m plus n I m comma n minus 2. Clear? This is how we will solve this given thing. But what is the logic here is, we can do it in two ways, that is we can take cos power n minus 1 into cos, or else sin power m minus 1 into sin. Anything is fine. Okay. But as for our definition derivation, we will do this first. If you want to derive this also, we can. When you can take sin power m minus 1 into sin here. Clear? But in general, we will use this formula for this when m is less than n, this for m when m is greater than n, for this cases. Clear? Did you understand this derivation? Fine. Shall we do one or two problems of this kind? Let's do. Look at the question here. He gave to find integral sin power 5 cos power 4 dx. So if you observe, what is m here? 5. What is n? 4. Is m greater than n? Yes. So m is greater than n. So we have to use this formula. Therefore, I 5 comma 4 is, let us substitute all the thing here. Sin power 5 minus 1 4x, cos power 5 plus 4 9x by 5 plus 4 9, plus m minus 1 5 minus 1 is 4, m plus n 5 plus 4 is 9, I m minus 2 comma n, m minus 2 that is nothing but 5 minus 2, that is 3 comma 4, right. Now here it is m less than n, so we have to use this formula. So let me write everything here. Sin power 4x cos power 9x by 9 plus 4 by 9 integral 3 comma 4. How do we do? Sin power 3 plus 1, that is 4x, cos power 3x by 7 plus n minus 1. What is n here? N minus 1 is 3, m plus n is 7. I again m comma n minus 2. What is m? 3 comma 4 minus 2 is 2. Is it clear? Similarly, it goes on simplifying. You can do one more step also. Is it right? 3 comma 2. If I substitute in this thing, I will get 3 minus 2 again I1. If I substitute 2, okay, so I will get it as 1 comma 2. Again we have to go to this. Clear? This is how we are going to simplify in a sequential form. Clear? Did you understand? By this problem we can end the chapter indefinite integrals. Okay, from where did we start? We should have a basic introduction about what is a differentiation, how do we differentiate the basic functions, right? Then only we can solve this integration, which is simply a inverse of a differentiation, right? So with that knowledge we will start the integration formulas. Then we did all simplifications, all everything. Yes, then we did integration by parts using small formulas, okay, and the next we used this partial fractions method, substitution method, and we had integration for different special functions, right? Fine. And finally we ended the chapter with this reduction techniques. Clear? Fine. Hope everything is clear for you. Good. This is for today. Let us meet in the next session with the next chapter of 2B. Thank you.